Increasing the rate of reaction has many industrial applications, but how can the rate be changed? And how can we alter it in the lab? There are two ways in which this experiment can be carried out, so decide with your teacher prior to the practical date which method best suits your expertise. Method 1. The upturned measuring cylinder. Set up your equipment now. Be prepared to write this down. Notice, the bung has been firmly pushed into the neck of the conical flask to prevent excess gas escapage. The measuring cylinder has been positioned upside down and has been securely clamped in place. And the delivery tube leads from the conical flask to the upturned measuring cylinder. Ensure your equipment is set up as shown in the diagram, unlike this. Notice how superfluous equipment has been used. An excess of measuring cylinders have been positioned near the site of experimentation. Many are the wrong way up. The conical flask has been incorrectly positioned. Although good safety practice, having the wet floor sign on the table is impractical and unnecessary. And the delivery tube does not lead from the conical to any of the measuring cylinders. Draw your results table now. You may need several attempts. Measure out the hydrochloric acid and place it into the conical flask. The measuring cylinder should be positioned upright for this part of the experiment. Drop the magnesium ribbon into the conical, immediately replacing the bung and starting the timer. Record the volume of gas produced at suitable time intervals. Now plot a graph of your results. The volume of gas produced should be placed on the y-axis with time along the x-axis. Now plot a curve of best fit through your points. You may need several attempts. Method 2. The disappearing cross. Now, set up your equipment as shown in the diagram. Ensure a suitable cross is drawn, unlike any of these. Caution! Do not drink the water. Placing the conical flask on the cross. Your equipment should look like this, with a stop clock to record the total time of reaction, measuring cylinders to transfer the hydrochloric acid and sodium thiosulfate, not forgetting the aforementioned reaction vessel and cross. But first, let's look at the chemistry. Notice how solid sulfur is formed from the reagents, causing the cross to fade. Now conduct the experiment, unlike this. Use the stop clock to measure the time taken for the cross to become invisible. This may take some time. how the cross is no longer visible, stop the stop clock. If, on the other hand, your cross never fades, it is likely your sample is water in its purest form. Pure water.